Okay, so I'm going to teach you how to find area, but first I kind of want to go over some shapes. So this is a parallelogram. It's any four-sided shape that has two sets of parallelograms, so it could be trapezoid, rectangle, square, or rhombus. Some shapes we're going to cover is rectangle and square. A rectangle is any four-sided shape with four right angles, same thing with a square, except for all the sides are the same length or congruent. The next one is triangle, so we have a lot of different kinds. It's a three-sided shape, but it can be equilateral, isosceles, scaling, acute, right, or obtuse. Then we have a trapezoid. So this one has at least one set of parallel lines. A rhombus, and it's a four-sided shape with congruent sides. And then a circle. So the first one we're going to start off with is the rectangle. So to find the area of a rectangle and square, it's the same thing. What you would do is 6 times 4. So it would be base times height. So base times height, which would give you 6 times 4, and that equals 24. So the area would be 24. Now, you do the same thing with the square. I'm going to kind of show you why it is that way. So if you look at the base right here, you just split it into 2 sections, and then for the height, you split it into another 2. And that's little squares inside of the square, which is also the area. And if you did 2 times 2, it equals 4. And if you look at each square, it's also 4. So that's how you know every time you do a square and a rectangle, it will be 4. The next one is going to be a triangle. So I'm going to talk about the right triangle first. And that would be this triangle. So what we do when we find any kind of triangle is we do 1/2 times base times height, because 2 triangles put together makes a square, and when we take one part of it away, it's half of the square. So if we do 1/2 times base times height, then that's how we know what the area is, half of what a square would be. So if I give you an example, let's say that our right triangle was 6. Oh wait, not right here, sorry. Ignore that. Let's say it's 6 and 2. For a square, we would do 6 times 2, and it would give us 12 for the area of a square, right? But instead, because it's a triangle and we're taking half of this away, we do 6 times 2 times 1/2, or 0.5, and that would give us 6. So the area of this triangle would be a 6. Okay, so how you would do this, let's kind of take this obtuse one. And what you do is usually the sine and cosine is one of the degrees. This would be the opposite of the degree, and the hypotenuse from the degree. This would be the adjacent from that, or the hypotenuse, and then opposite and adjacent. So if we take a look at our, actually, let's do this one. This one's going to be a little easier. An acute triangle is when all angles are smaller than 90 degrees. So let's make our acute triangle. Now, this is a little different than how you would solve for a right triangle, because we don't have a straight line like we do in our right triangle, right? It's not a complete straight line. This is more slanted. So let's just say that we know the degree right here. Let's say it is 64. And let's say that our base is 4. Now, how do we find an area with this information? One way we can do it is by splitting this triangle in half. Now what happens when we split it in half is we get two separate triangles that are the exact same, if my drawings were a little more perfect, but in the real world they are the same. So half of 64, since we split this angle in half, is 32 on one side of the triangle and 32 on the other side, since they are exactly the same. That means our base we split in half too. So it's 2 and 2. The only problem is we don't know what our height is. So we're gonna mark it as x. Now there are other equations you can use, and you can use it to help you find the scalene triangle, isosceles obtuse. You can use this same formula. So we have cosine, sine, and tangent. So now with sine we have opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we're gonna try to match the best equation for this triangle. Now we know what our angle is, right? So we're gonna put 32 right here. 32 equals, from this angle we know what our opposite is. Opposite is right across, which is 2. Okay, we don't know our adjacent, which is the other length right next to the angle, because it's our height. We don't know what it is, it's x. And we also don't know what our hypotenuse is. So the best equation we can do with what we know is we have our opposite and we don't have our adjacent. So we're gonna use this equation, tangent, with opposite over adjacent. So opposite is 2 and adjacent is our x value. And since we use tangent, we're gonna put our tan right in front of 32. Now how we're gonna solve this to get our x by itself, what we are going to do is times x to both sides. So you get x times tangent of 32 equals 2. But we still don't have x by ourselves yet. So we're going to divide it by tangent of 32 to cancel it out, and divide 2 by tangent of 32. Now first, what I like to do in my calculator is solve for tangent. So for tangent, I got a value that was about, for tangent of 32 gave me about 0.66. So now that we know that, we can go back here and go, okay, 2 divided by 0.66, which gave me 3.03. Now, all of this that we did only solved for one part of our triangle, right? So now we gotta add it together. What we can do is we can either times this by 2 or just add the same value. So we could do 3.03 plus 3.03, which gives us 6.03 for the area of the entire triangle here. So that's how we can find the area of our triangle for acute, obtuse, scalene, or whatever. Okay, so the next shape we're going to do is trapezoid, and it's very similar to our triangle, because the acute triangle we did because we don't know what the height is. Since we don't have a straight line for the height, it's not really accurate. So what we can do is, let's just say we drew a line, we gave us our straight height and it was 5, and let's say we made another one like this, right? Let's just say that this base right here was worth 2. And this base right here was worth 4. How would you solve it? One way you could do is try to find the area of both triangles. Do 5 times 2 times 1/2. And find 5 times 2 for the area of this. Or what I like to do, it's less work and makes it easier. Think of it like this. So we have our trapezoid. This is worth 4. This is the height is 5 and 2 and 2 for our bases. So what we can do, we do know 5 times 4 gives us 20. Okay? And we could solve each triangle individually, or we can break it and move it. And it gives us a mini triangle, a rectangle. If you take that away, that's a rectangle when you put it together. And we could do 2 times 2, which is 4, right? So we have the area of 4 and 20. What we're gonna do is add them together. So now our area equals 24. And we know that because if we put it back, it's still our rectangle or our trapezoid. We didn't take away any, we didn't add any. All we did was break it apart just a little, put it together so it makes it easier for us to find the area. This is kind of very similar to the trapezoid. We don't know what our straight lines are because we don't have any, but we can make our own and we can break it apart. Oops. So there we go. We broke it apart and now we have 2 triangles. And what we can do is, let's say our base is 4, and then let's say we make another line and we go straight down like this. Now we have 4 right angles. And let's say the height on here, on one side right here, is 4. Okay, let's just say it's 4. We could do one or two things. We could find the area of one triangle and times it by 4 because we know that they're all the same. Or we could move this one over here. And kind of like how we did with the trapezoid. So let's say these are our 2 right triangles that you see right here. Look, all we do is add it together. So on the paper, it would look like this. We take this triangle here, just add it here. So now we have our, we have to divide 4 by 2 since that whole thing is 4. Half of that is 2, so that's 2, right? And we know that one side of the height is 4. So all we do is 2 times 4. And that gives us 8. And the bottom half is the exact same thing. So we can, again, like our little rectangle, bring this over here. I'll use a different color. Over here. We know that this side of 4 is the same length right here, so this is also a 4. And we know that it's the same base, so it's also a 2, and it gives us an area of 8. Now we have 2 areas, very similar to our trapezoid. We add it together. So we go 8 times 8 equals 16. Or, sorry, not 6. Or what? It's not 8 times 8. I meant to put 8 plus 8. My bad. So I'll just rewrite it. So 8 plus 8 equals 64. Or why am I saying that? I don't know. I'm thinking times. It's not times. It's 16. So 8 plus 8 is 16. 16 is our area. That's how we can find with rhombus. So if you see a pattern, just like the trapezoid, when you move your shapes together, for this trapezoid and the rhombus, see how it's just a big rectangle now? We made this one long rectangle. It's the same way you would solve for the area of the rectangle we did earlier. Same way. Base times height. So, oh, is it not that one? It is this one. Same way, so it's base times height. And when you can move your shapes and you learn how to cut them, move them, and put them together without adding or taking away, just like that, you can find base times height just by rearranging your shapes. And you can put them back and put this back, and it still makes a rhombus. Okay, the last one that we have is a circle. Now, this one's a little tricky because it has no sides. Okay, so if you know what pi is, I'm just rounding it to the nearest 4 decimals. So pi gives us 3.1416. Then we have our radius, which is 6. So you times it by 6 squared. 6 squared is 36. So 3.1416 times 36 equals 113.0976. Or you could say 113.1. However you want to round it, but to the nearest 4, that's what it is. So that's how you find the area of the circle. And it's all the shapes are similar in different ways. You can split the shapes. You can add them back together. You know, you can do a lot with the shapes. And even splitting the shapes just makes it easier, like kind of we did earlier. Makes it easier for you to solve if you can learn how to split them and then even put them back together. Put them back together to show you the original shape you had. So that's how you find area.